Hey Grammar 6, happy Friday. So today we're going to be talking about mass and weight. So you should be on lesson 102. You should have already done your facts practice and your mental math warm-up, including your problem solving. By now you know that you should have those done before you start this video. So I know it says lesson 117 up here, but disregard, this is from 1997. In your book, you should be on page 551 and it's lesson 102. And today we're going to talk about mass and weight, which is concepts you have probably talked about in your science classes already. And so what mass and weight have to do with our lesson today is we're going to talk about converting amounts between different measurements. So first off, we need to know what mass is. And everything in our world, everything is composed of matter. The amount of matter in an object is called its mass. So while we do not use the metric system here, the metric system uses the mass of objects in milligrams, grams, and kilograms. So if you look below, you'll see 3 examples of a measurement. So a grain of salt is 1 milligram. A paper clip is 1 gram, and a math book is 1 kilogram. So a milligram is 1 gram is equal to 1,000 milligrams. These would be equal amounts. It's just different units of measurement. And then again, 1,000 grams is equal to 1 kilogram. So that'd be similar to if you were to stack 1,000 paper clips that measure 1 gram each, you would equal the weight of the math book, which is 1 kilogram. So second, the next thing that we need to talk about is weight. So weight is So let's back it up a little bit. So we know that mass does not change regardless of where you are. A paperclip is still going to be 1 gram, whether it is here on Earth, on the moon, or in orbit. So in other words, the mass of an object does not change with changes in the force of gravity. However, what does change is weight. And in your book, you should have weight highlighted. And what weight is the weight of an object does change with changes in the force of gravity. So I'm going to show you guys a YouTube video that does a really good job of explaining mass and weight. All right, so here we go, guys. Don't know why it's not playing. Hold on.
Let's accept it. Most of us think that mass and weight are pretty much the same thing. Are they? No, they're not. There's a very simple way to understand the difference. Mass is simply the amount of matter that's present in the object. Now consider 2 situations. One in which an object is on the Earth, and second in which the same object is on the moon. Will the mass of the object be different in these cases? To answer this question, we ask ourselves another simple question. Will the amount of matter present in the object be different in these cases? Absolutely not. The matter in the object is not changing at all, which is why the mass will be the same in each of the cases. The mass of an object remains constant no matter where it is placed. The standard metric unit of mass is the kilogram. Another concept we'd learnt about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are 2 places, place A and place B, and there's an object of mass m. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. The mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using...
Back to our textbook now. So we just talked about the difference between mass and weight. So let's look at some examples here using the US customary system. So we use ounces, pounds, and tons compared to, again, milligrams, grams, and kilograms in the metric system. So an envelope and letter are about 1 ounce. 16 ounces is 1 pound, which is the same weight as a shoe. And then a small car is 1 ton, which is equivalent to 2,000 pounds. So let's look at this example. It says 2 kilograms is how many grams? Well, if we refer back to this right here, the paperclip and the math book example, we know that 1 kilogram is 1,000 grams. Just like 1 textbook is the same as 1,000 paper clips. So 2 kilograms is going to be 2,000 grams. Let's go on to example 2. You have a little different one than I do. I just have this example right here. I don't have the addition problem that you have. So let's just do the subtraction one. So here we're subtracting 9 pounds and 10 ounces minus 7 pounds and 12 ounces. So here we can't take 12 ounces away from 10 ounces, but we can rewrite 9 pounds and 10 ounces to something else. Here what we're going to do is we're going to convert 9 pounds and 10 ounces to 8 pounds and 26 ounces. We took 1 whole pound away from 9 and made it 8. But remember, 1 pound is equal to 16 ounces. So we added the 16 ounces to the 10 ounces to get 26 ounces. Now we have a number greater than 10 that still represents 9 pounds, 10 ounces, because 8 pounds and 26 ounces is equivalent. And we can subtract and find the difference. So at this point, guys, go ahead and do your lesson practice. You should be doing A through E. Have your parents check it. And of course, if you have any questions, be sure to reach out to me, email me, whatever, anything that I can do to help you guys. So anyway, guys, I hope you guys have a great weekend and looking forward to doing some more work next week. Bye.